Okay, this is our third look at this problem. The problem statement's like this: arrange the numbers 1 through 9 in 3 rows and 3 columns so that a 3-digit number across the middle row is double that of the first row, and the third row is triple that of the first row. So we rearrange the numbers 1 through 9 in this fashion, or in these positions. Before we did this problem with variables a through I with nested loops. The next time we did row at a time, row X, Y, and Z, so top, middle, and bottom row, and tried it that way. The problem with these two solutions is as we iterate through the possible combinations there by using nested for loops, we have some solutions like 1, 1, 1 on the first row, or 4, 4, 4 on the next row that duplicate the digits. So what we really want to do is find every combination of 1 through 9 that fits in this pattern. And so that's permutation. So we're going to do it a little bit different way, hopefully a little bit more efficient way, by using permutations. And there are several permutation algorithms we can use. What we're going to do today anyway is use a built-in library. So remember, the pound include for IO stream is just that's where we use that. I'm going to put a comment statement up here. That's for our cout. And so what we're going to do is do another pound include, and we're going to include a library called algorithm. And what we're going to do with algorithm, that's going to give us our permutation and a sort function that we're going to use. Okay, and so this also deals with arrays. So I want to create an array called I, and I'm just going to make it generic, and we'll initialize that to initially I'm just going to put the numbers 1, 2, and 3 in there, and the reason we'll do that is just to see how the permutation is actually going to work. So what we would expect is every combination of the numbers 1, 2, and 3 once we get our loop set up and everything working. So we're going to use sort to make sure our data is sorted, and we'll just sort the array I, and we'll have 3 elements, so we'll do I plus 3, and that should sort our array. So we'll set up a do loop here now to do our permutations. So we'll do while, and we'll call our next permutation, and notice I listed it here, std : and then everything's in our standard namespace, so I just put using namespace standard here. So we're not doing std : next permutation because I've got names using namespace standard. So it'll just be next _ permutation, and then we'll do the same thing. We'll put the array I in here, and of course we got 3 elements, so I'll put in I plus 3. Okay, and now inside my loop I need to output each element so I can see what the array looks like after each permutation. And so to do that, I'm just going to look at the first element, so I sub 0. So the first element followed by the second element, I sub 1, and then I sub 2 would be our 3 elements in the array. And then I'll put in an inline, and we'll see how this runs. So I'm going to go ahead and execute, compile and run. And this is our result. So we get the numbers 1, 2, 3, and then it flips 2 and 3 here. And so we as we go through, we get all the different combinations of 1 through 3. And we can kind of double check that, or at least do one check. If you remember your permutations, the number of combinations is going to be the same thing as the factorial, since we have 3 numbers. 3 factorial, 1 times 2 times 3 is 6. So 1, 2, 3, 4, 5, 6 different ways. And if you look at it closely, you can see we've done every combination of 1, 2, and 3. So just to kind of see how this permutation function is working in this loop. Now we need to set it up so that we do our 1 through 9 here. And one thing I want to talk about is kind of program maintenance, and because I'm prone to make errors here. As I change this to 9, I would be tempted to come up here and just add the other numbers. And remember, I have a sort and a permutation where I have the number of elements here referred to, kind of hard-coded constant in there. So what I want to do is change that to a variable and make it a little bit more robust. So if I change the data here, I'm not creating problems for myself in the future. So let's make this a little bit easier to maintain. I'm going to create a variable called element count, so the number of elements in the array, and I'm just going to use the old standard size of my array divided by the size of the first element in the array, and that will give me the number of elements in the array. And then I just need to simply come in here, instead of 3, put in element count, and instead of 3 here, I'll put in element count. And so that'll make it more dynamic. So if I come in here and I change this to, let's say 4, we can compile and run this with 4 in here, and I don't have to remember to go into each of these places and change that. Let's test that out, compile and run, and we get all the permutations of the numbers 1 through 4 here. So we don't want to go just print all the permutations, so let's go back and we'll get rid of this and increase our array here to hold all 9 numbers that we want to combine. So remember, we're going to look at each row, and so I'm going to go by the row method where we're looking at x, y, and z. So I'm just going to create a variable for each row, x, y, and z, and then I'm going to set x equal to 100 times, and if we're looking at our chart where it was 1, 2, and 3 across the top, I'm going to have I sub 0, okay, and that being the first element, 10 times I sub 1, the second element, and simply the third element, I sub 2. So those 3 positions in our array is going to represent the numbers in the first row. Okay, and then y, same thing, we're going to do 100 times the next element is just 3, so we'll let that represent the hundreds place. So the second row times 10, or 10 times element sub 4 being the tens place of the second row and the ones place of the second row. Okay, and then we'll do the same thing for z with the rest of the elements of the array, and that gives us our numbers. Now the reason I'm breaking down the rows is I still have to check my conditions. Is row 2 double that of row 1? So I'm going to put my if statement in here and say 2 times row 1, which is x, is that equal to the second row, which is y. And we also need the third row to be triple that of the first row. So we'll say 3 times x, which is the first row, is that equal to z. Okay, and when in doubt, add a set of parentheses here. So we're going to check both of these conditions. As the second row, twice that of the first row is the third row, 3 times that of the first row. Different in this solution, we don't have to throw out all the values where there might be duplicates, because we have no duplicates. We're simply rearranging the numbers 1 through 9. So we don't have that extra step of weeding out invalid solutions where we have duplicates. So we'll just see out each row. So x, go to the next line, print y, and print z. I'll put a couple of end lines in here so that for each solution, we've seen before there's multiple solutions to this. We have everything on a separate line. So let's compile and run this, see how we do. and we get the 4 solutions that we would expect a little bit quicker than before. We were doing like 1.6, 1.7 seconds. So throwing out those, not having to throw out the duplicate values is helping us efficiency wise. I did not put solution count in here, so let me change this a little bit and go ahead and put our saw count in here, so we have that one line that says what our solution count is. This is the point where I potentially could make a mistake, because notice I indented here for my if statement, and remember, if statements work with only the next line, so only this line is conditional at this point. Saw count, I'm going to get essentially the number of permutations come out of this thing if I leave it like this. So sometimes I recommend, if you're doing if statements or for loops, things like that require the braces, you might just put them anyway to keep yourself from making a mistake, at least until you get used to the language a little bit more. So I can't just indent. C++ doesn't go by indentation. I need to add a set of braces here. So brace to open the code block, and a close brace since I added my solution count in here. And then I need to add my output statement at the end to display the number of solutions. Okay, and so let's execute that and see how that works. And so with that one, I get 4 solutions, same 4 we had before, in a pretty short amount of time. I'll try that one more time just to see. And that one runs a little bit even faster, so 0.0645, so a little bit better than the 1.6 or 1.7 seconds we had before. And that's by using permutations. So we're just using every combination of rearranging those 9 numbers and then checking the solutions to see which one. The second row is twice out of the first, and the third row is 3 times of the first. And this is what we came up with. So hopefully this is helpful and you learned a few things, and I'll see you next time.